Before the stars, before the planets, before time itself had any meaning, there was nothing. In the next 25 minutes, you are going to witness the birth of the universe. Not a theory, not a guess, the actual story, frame by frame, of how everything you have ever seen, touched, or loved came from a single point smaller than the period at the end of this sentence. And the most terrifying part, it could have gone wrong in 1,000 different ways, and none of us would be here to know it. So, what actually is the Big Bang? Let me be honest with you right now, because most people think they know what it is, and most people are wrong. The Big Bang was not an explosion, not like a bomb going off, not like a star exploding, nothing like that. The Big Bang was the expansion of space itself. There was no center, there was no edge, there was no before. Space, the very fabric of reality, began to stretch, and everything in it stretched with it. Imagine you're a dot drawn on a balloon. You inflate the balloon, and suddenly every other dot seems to be moving away from you. But you're not in the center of the balloon. Every dot is moving away from every other dot equally. That's our universe. And here's the kicker. We can actually watch this happen. In 1929, Edwin Hubble discovered that distant galaxies aren't sitting still. They are racing away from us. The further away they are, the faster they recede. This is called cosmic redshift, light stretching as space itself stretches. So physicists did something brilliant. They ran the math backwards. If everything is moving apart now, then billions of years ago, everything must have been closer together. Keep going back far enough, and everything in the observable universe, 2 trillion galaxies, was compressed into a region smaller than an atom. Smaller than an atom. That was 13.8 billion years ago. And then, for reasons we still don't fully understand, it began to expand. The Big Bang had begun. Now pay attention, because this next part happens so fast, it will make your head spin. The entire story of the universe's first second is so wild, so violent, so utterly alien. It is like nothing that has ever existed since. Temperature, infinite. Density, infinite. Time, 0. The laws of physics as we know them do not exist yet. Not even Einstein's equations can describe this moment. We simply do not have the math to peer behind this curtain. This is called the Planck Epoch, the first 10 to the power of -43 seconds. That number is so small, if you compared it to 1 second, it would be like comparing 1 second to the entire age of the universe. Something extraordinary happens. The universe undergoes inflation, expanding faster than the speed of light. Wait, didn't Einstein say nothing can travel faster than light? He did. Einstein say nothing can travel faster than light. He did. Einstein say nothing can travel faster than light. He did. Einstein and there. might say. But space itself has no speed limit. In less than a blink of time too small to name, the universe grows from subatomic size to roughly the size of a grapefruit holding everything that would become 2 trillion galaxies. This inflation is what gave the universe its smoothness, ironing out wrinkles the way you'd smooth a crumpled sheet by pulling it tight. But it also locked in tiny quantum fluctuations, microscopic ripples in the density of matter. Those ripples, they're why galaxies exist. They're why you exist. Without those imperfections, the universe would be perfectly smooth, perfectly boring, and perfectly dead. As the universe cools, even slightly, the unified force that governed everything begins to split. First gravity peels away, then the strong nuclear force, then electromagnetism and the weak force separate from each other. 4 fundamental forces, 4 invisible hands that would sculpt every atom, every star, every living cell, forever. The universe is still unimaginably hot, but it's cool enough now for the first building blocks of matter to form. Quarks, tiny beyond comprehension. 3 quarks snap together, bound by the strong nuclear force, to form the first protons and neutrons, the raw ingredients of every atom, of every molecule of your body. They are being forged right now in a universe less than 1 second old. 1 second after the Big Bang, the universe is a raging soup of protons, neutrons, electrons, photons, and neutrinos. Neutrinos are ghost particles, so weakly interacting that they pass straight through solid matter. Right now, as you watch this video, approximately 100 trillion neutrinos born in our sun are passing through your body every second. You'll never feel a single one. At 1 second old, the universe is cool enough that neutrinos stop interacting with everything else. They stream outward, free, carrying a ghost image of this exact moment in cosmic history. We can detect them today. They're still out there, filling the universe, a relic of the first second of everything. Three minutes. That's all it takes. In 3 minutes, the universe will forge the first atoms. This process is called Big Bang nuclear synthesis, and it is, without exaggeration, the most important cooking event in all of history. At 3 minutes old, the universe has cooled to about 1 billion degrees Kelvin. That's still 6 times hotter than the core of the sun. But it's cool enough for protons and neutrons to fuse without immediately being torn apart. 2 protons, 2 neutrons fuse together. The first helium nucleus is born. By the time this window of nuclear synthesis closes, about 20 minutes after the Big Bang, the universe has produced 75% hydrogen, 1 proton, the simplest atom, 25% helium, 2 protons, 2 neutrons, trace amounts of lithium. That's it. That's the entire menu. 3 elements. And yet, from just these 3 ingredients, every star, every planet, every ocean, every heartbeat was somehow going to be built. The universe is 20 minutes old, and it has already written the blueprint for everything. Now comes the part nobody talks about. The Dark Age. You've heard of the cosmic dark ages of human history. Medieval Europe, the burning of the Library of Alexandria, but the universe had its own dark age, and it lasted 380,000 years. After nucleosynthesis, the universe is flooded with photons, particles of light. But here's the problem. The universe is still so dense, so packed with electrons and plasma, that light cannot travel freely. Every photon immediately collides with an electron and scatters. The universe is opaque. You could not see your own hand if you were inside it. There is no darkness quite like this. The darkness of a universe that exists, but cannot be seen. The temperature has dropped to about 3000 Kelvin, cool enough for electrons to finally bind to protons, forming the first complete, stable hydrogen atoms, with electrons now locked into atoms. There are no more free electrons to scatter photons. Light is released. For the first time in 380,000 years, the universe becomes transparent. Photons stream freely in all directions. This is called the surface of last scattering, and the light released in that moment is still traveling today. We call it the cosmic microwave background radiation. This ancient light, now stretched by expansion into microwave frequencies, fills the entire sky in every direction. It is the oldest photograph in existence, a baby picture of the universe, taken 380,000 years after its birth, and those tiny ripples in temperature, those fluctuations in the CMB, those are the seeds from which everything grew. For hundreds of millions of years after the Big Bang, there was still darkness. No stars, no galaxies, no light, just hydrogen, helium, and gravity. But gravity is patient. Those tiny fluctuations in the early universe, the ones planted by inflation, began to work. Dense regions pulled in more matter. Slightly denser patches attracted their neighbors. Over millions of years, the gas clouds grew denser and denser, hotter and hotter. And then, somewhere in the deep dark of the universe, about 200 million years after the Big Bang, a star ignites. The first stars were nothing like our sun. They were monsters. We call them population 3 stars, and they were made of almost pure hydrogen and helium. No metals, no complexity. Some were hundreds of times the mass of our sun, burning so furiously, so hot, so brilliantly, that they lived for only a few million years before dying in catastrophic explosions. But in their death, something extraordinary happened. Inside those stellar furnaces, hydrogen and helium were fused into heavier elements: carbon, nitrogen, oxygen, silicon, iron, insteosum-4D. Carl Sagan said it best: "We are made of star stuff. Every atom of carbon in your body was once inside a star that died before our sun was born. Every breath of oxygen you take was forged in stellar nuclear furnaces billions of years ago. You are not just watching the history of the universe. You are the universe watching itself." Fast forward. We're now 9 billion years, After the Big Bang, galaxies have formed, stars have lived and died by the billions. In a quiet arm of the Milky Way, a galaxy that formed from ancient mergers of smaller galaxies, a cloud of gas and dust begins to collapse. Maybe a nearby supernova pushed it, a gravitational nudge from a passing star. Whatever the trigger, this cloud begins to spin. At its center, a dense core grows hotter and hotter, until 4.6 billion years ago, a new star ignites. Our Sun. Around it, the remaining gas and dust flattens into a spinning disk. Rocks collide, pebbles become boulders, boulders become planetesimals. Over millions of years, the planets form. Then, something violent happens. A Mars-sized body slams into the young Earth. The collision is catastrophic. Debris flies into orbit. Over thousands of years, that debris coalesces. The Moon is born. An Earth, still glowing with heat, still bombarded by asteroids, slowly cools. Water arrives on icy comets, oceans form, and somewhere in those warm, chemical-rich oceans, life begins. Now, I have to ask you something that has kept physicists and philosophers awake at night for 100 years. What came before the Big Bang? The honest answer is, we don't know. We can't know. Not yet. Possibly not ever. The Big Bang isn't just the beginning of matter and energy. It's the beginning of space and time itself. Asking what came before the Big Bang is a little like asking what's south of the South Pole. The question might not even be valid, but that hasn't stopped physicists from trying. Some physicists propose the universe bounces like a cosmic heartbeat. Big Bang, expansion, contraction, big crunch, and then a new Big Bang. On and on, forever. No beginning, no end. Others argue our Big Bang was just one of an infinite number of Big Bangs, each creating a separate universe with its own laws of physics. Most of those universes are dead. Ours happen to be alive friendly by pure cosmic luck or necessity. Stephen Hawking proposed that at the quantum level, where nothing is truly stable, a universe could spontaneously emerge from nothing. Not from nothing, like an empty box, but from the quantum vacuum, where particles wink in and out of existence constantly. The universe may have, quite literally, been born from nothing. The truth? We don't know which, if any, of these is correct. And that is beautiful, because it means we're still at the beginning. We are the universe's first species to look back and ask, where did I come from? And we're barely getting started. 13.8 billion years. That's how long the universe has been building toward you. Every supernova that seeded the cosmos with carbon, every collision that shaped your planet, every ocean that nurtured the first life, every generation that lived, loved, and died, so that eventually, inexplicably, impossibly, you would be born. In a universe of 2 trillion galaxies, in a galaxy of 300 billion stars, on a planet orbiting a perfectly average sun, life emerged. consciousness emerged, and that consciousness looked up at the stars and asked, where did this all come from? You are 13.8 billion years of cosmic history, walking around, breathing, thinking, feeling. The universe is not something that happened to you. You are something that happened to the universe. If this video made you feel something, if it made you look up at the sky a little differently, that's exactly what we're here for. Hit subscribe, because every week we explore the questions that keep humanity reaching outward. What part of the Big Bang hits you the hardest? The fact that it all started from nothing? The fact that you're made of ancient star stuff? Or the fact that we still don't know what came before? Let's talk, and until next time, keep looking up.